Okay, let's do a review together. This is Periodics Trend Unit 4 review. All right, part 1 here is box the metals, circle the metalloids, and do nothing to the non-metals. Okay, so the first thing I want to do is identify metalloids, which you know includes boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. So any of those that I see on here, I'm going to circle. Let's see, where are my metalloids? Are there any metalloids on here? Oh yeah, sure there are. Boron, silicon, germanium, and what else? Is tellurium on here? Nope. Is polonium on here? Nope. Is arsenic or antimony on here? Arsenic. No antimony, silicon, germanium. Is there any germanium? Oh, I already got it. I think that's it. Okay, so then we're doing nothing with the non-metals. Okay, so aluminum, box the metals. Aluminum's a metal. Beryllium's a metal. Remember, anything to the left of this staircase, metal. Anything to the right of this staircase, non-metal. Bromine, non-metal. Carbon, non-metal. Calcium, metal. Cobalt, metal. Gallium, metal. Iodine, non-metal. Potassium, metal. Sodium is a metal. Phosphorus is a non-metal. Sulfur is a non-metal. Selenium is a non-metal. Well, there we go. So that should be pretty easy. You should know that. Knowing that everything over here is metals, everything over here is non-metals. And then basically knowing that boron and then every two are metalloids. So boron, 1, 2, 1, 2, 1, 2. You got to learn those steps. You got to learn where the metalloids are. That's just something that has to be remembered, right? Okay. So we're going to move on to this next part, electron config, and what we can learn from electron config. So what we know about electron config. So the first one is stable, yes or no. I don't like stable because that's a reactivity term, but we should say reactive or non-reactive. We know that all the non-reactive things are over here, and that this is basically the P block, and so this is P6. So this is 2P6, 3P6, 4P6, 5P6, 6P6. So anything they're gonna say is, quote, stable is going to end in P6. So this ends in P6. This ends in P6, so these are the only two quote-unquote stable things, and everything else is no, 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 no. And then the group family. Okay, so P6, P5, P4, P3, P2, P1, S2, S1, right? So if it ends in P6, it is noble gas. If it ends in S2, it is alkali earth metal. Alkali earth metal. Sorry about my writing today. If it ends in P4, 1, 2, 3, 4, that's the oxygen group, the oxygen family. S2, if it ends in S2, it's an alkali earth metal. P1 is going to be the boron family, because remember, the not very imaginative way, this is boron family, carbon family, nitrogen family, oxygen family, halogens, noble gases. Then we get into some original names. Alkali metals, alkali earth metals, transition metals, lanthanides, and actinides, right? Okay. P6, that's a noble gas or an ion. Hard to say what it is. Gain or lose electrons. Okay, if it's in P6, it's not going to do either, right? If it's in P1, we can just look at the things in P1. Here's P1. Here's the oxidation number. The oxidation number tells me that these things tend to lose electrons because they're positively charged, and that makes sense. It has 3 valence electrons. Things that have 3 valence electrons tend to lose 3 valence electrons and not gain 5 to get to a stable octet. So, lose 3. So if it's in, wait a minute, where are we at? Okay. All right, P6. All right, so the next one down is S2. So that's this group. That's +2. They tend to lose 2. And that is a metal, non-metal. Because we know noble gases are all nonmetals, right? Oxygen family, it's in 3p4, so 1, 2, 3, 4, that's this family, and they tend to, their oxidation number is -2. They have 6 valence electrons, so they tend to gain 2 electrons. Gain 2, and that is a non-metal. S2, definitely a metal, because it's over here. And if it's S2, that means it's in the +2, which means it tends to lose 2 electrons. Okay, P1, so it's this group, so it's the boron family. They are charged +3. That is the ion they tend to become, which means they tend to lose 3 electrons. And in the boron family, 4p1, 4p1, that is a metal. See, they tried to sneak it in there on you because it's right here. It's 4p1, metal. Metal. And then noble gas, non-metal. And that's what you're doing. I mean, you could count up the electrons, decide what element it is. Like I could have counted these up, but I can also look at 4, the P group, 6, and know that this is krypton. And then I know all about it. Right? Right. Okay, let's move on with this page here. What pattern do you notice for all elements that are stable? N, X, P, 6. Where are they located? In noble gases? No, noble gases. Gases. Are they metals? No. No. And now we're making a big assumption here too, because we're assuming that that's not an ion. Remember, all ions end in P6. They want to become noble gases. These oxygen tends to gain 2 electrons. If it gains 2 electrons, it has the same electron configuration as neon. So it ends in P6. So unless you tell me this is all uncharged neutral atoms, then you can't really say for positive what atom they are or what element they are. But what do you notice about elements that gain electrons to become stable? Those non-metals, right? Mostly non-metals. Things that gain electrons are going to have negative oxidation numbers. Hey, guess what? That's all non-metals that are to the right of that stair step. Where are they located? On the right side of the periodic table. And are they metals? Yeah, they're non-metals, and they tend to, gain electrons. What do you notice about elements that gain electrons to become stable? Well, that's kind of silly. They're all non-metals. They're all to the right. I mean, I notice a lot of things. I notice that a lot of them tend to be gases. I know that they make up anions when they become ionic. I know that they're right beside noble gases. Like I notice a lot of things. So you got to be more specific. But yeah, that's a pretty good answer, right? What do you notice about elements that lose electrons to become stable? Okay, elements that lose electrons to become stable. So things that lose electrons are basically all metals, like +3, +2, +1. All these things have positive oxidation numbers. So it's metals. They're on the left side of the staircase. By the way, if I haven't called it that, the zigzag, the staircase, whatever you want to call it, to the left, everything metal, to the right, everything non-metal, right? Which elements are most similar and why? Well, chemically similar, or chemical properties are similar, are groups. So basically, any column, all these things blow up in water because they have one valence electron, which is really easy to pop off a hydrogen. So all these things blow up in water. They're all chemically similar because they have the same number of valence electrons, right? So groups or columns, if you want to call them that. Groups or columns because they have the same number of valence electrons. Same number of valence electrons, right? Yes. Okay. So let's continue. I'm going to end this video. I'm going to start another one. So the end of page 1 is part 1.